quiet of a tank, captured dolphins produce something no one had ever heard before. Unique whistles. Individual, unmistakable. Each animal calling with its own sound, over and over, the same pattern, always recognizable. In 1965, two researchers sitting beside this tank noticed something that would not leave their minds. These animals were producing sounds that belonged to no other creature on Earth. Not random clicks, not warning signals, but something far stranger. For decades, science insisted this was meaningless, a byproduct of anatomy, the vocal equivalent of a fingerprint. Something involuntary, produced by the shape of the animal's larynx, no more intentional than the timbre of a human voice. The orthodoxy was absolute. Animals do not name each other. Names require symbolic thought. Names are human. The researchers looked at the data and disagreed, but they could not prove it.
How do you prove that a sound is actually a name? A name must be learned, not inherited. A name must exist independently of the speaker's voice. A name must be used intentionally to identify another being. Without evidence for all three, it remains nothing more than a guess dressed in scientific language. For decades, the dolphin whistle remained a mystery wrapped in skepticism.
Off the coast of Florida, in shallow waters so clear you can see the sand beneath your feet, a bottlenose dolphin's newborn calf lies beside its mother. The calf is 4 months old. It babbles, producing chaotic, unstructured sounds. Its brain is listening. Its throat is learning. And its mother is doing something extraordinary. When she turns toward her calf, her signature whistle changes. The frequency range expands. The pitch becomes 90% wider than her normal social calls. She is reshaping her own voice to teach, a phenomenon called motherese. Human mothers do exactly this, raising the pitch of their voices, exaggerating the contours of speech. They flood their infant's brain with dopamine through neurochemical reward. For dolphins, this teaching is critical.
These newborns will soon move through an ocean where visibility fails entirely. They will be separated from their mothers. They will need to survive in a society more complex than most primate communities. The name must be learned early. By the 6th month of life, the dolphin calf has crystallized its own unique signature whistle, a frequency-modulated contour that will remain unchanged for the rest of its life. It has chosen an identity, distinguishable from every other individual in its social universe.
But the calf's learning tells us only part of the story. Yes, names are learned, but are they truly names? At 21 days old, parrotlet chicks in the Venezuelan rainforest begin developing something similar. When researchers transported eggs between unrelated nests, the foster chicks did not inherit their biological parents' calls. They adopted the vocalizations their adoptive tutors quietly directed at them during imprinting. The name is given, not genetic. This confirms learning. But it still does not answer the fundamental question. How do we know these sounds function as names, rather than simply distinctive voices? The answer came from an experiment no one expected. In 2006, in Sarasota Bay, a research team took 14 wild dolphins and posed a radical test. They would create synthetic whistles, not recordings of actual dolphins, but artificial sounds. They isolated the fundamental frequency modulation, the geometric shape of a whistle, and stripped away everything else. They removed voice. They removed timbre. They removed the individual acoustic fingerprint of the caller. All that remained was the pure mathematical contour, the shape. The skeleton of the sound. Then they played these skeletal whistles to the dolphins. The animals recognized their own synthetic contours with perfect accuracy. More crucially, they responded significantly more to the synthetic contours of their closest relatives than to unrelated dolphins. The identity was encoded in geometry alone, not in voice, not in timbre, in the abstract shape of the sound itself. This is identical to how humans recognize a melody. Hum a song, whistle it, play it on a piano. The identity remains because melody is about the relationship between notes, not the instrument. The dolphin had independently discovered the same principle. A name is not a voice. A name is a pattern. The barrier had been broken. The whistle was a name. But what about the third requirement? Names must be used intentionally to identify others. Within a few years, researchers discovered that dolphins do not merely broadcast their names. They address each other with them. In interactive playback experiments, dolphins were played their own signature whistle, but with a critical twist. The whistle was directed at them. It was calling them specifically, not just announcing identity. The dolphins turned toward the speaker. They responded with their own signature whistle. The success rate was 83%. In the wild, separated dolphins call out using the signature whistles of specific individuals, and those individuals turn and come toward them. They had built an oceanic address book. Now the question deepens. What does a name actually do for an animal? In the shallow turquoise waters of Shark Bay, Western Australia, a female dolphin has been herded repeatedly by a particular male. The herding is aggressive, coercive. It is designed to isolate her from the pod. She has suffered. Researchers played a recording of that specific male's signature whistle, just the acoustic label of his identity, to the female. Instantly, she changed her swimming direction. She veered away from the speaker. She used his name to anticipate danger before he even arrived. The whistle carried not just identity, but reputation. A name was a file, a record, a way of storing behavioral history in a single sound. The dolphins had independently invented something that humans take for granted, a reputation system. This ability to maintain individualized knowledge about others requires a sophisticated architecture in the brain. And yet, naming was not unique to dolphins. Deep in the African savanna, in 2024, researchers analyzed 469 distinct elephant rumbles using machine learning. The algorithm could predict the intended recipient at a rate of 27.5%, more than 3 times the chance baseline. The elephants were addressing each other by name. But here is what makes this profound. Unlike dolphins, who copy their companions' acoustic contours, elephants use arbitrary, non-imitative labels. A completely different sound represents each individual. It is purely symbolic. In the rainforests of South America, the common marmoset discovered the same solution. These small primates adjusted the fine acoustic parameters of their calls to address specific family members. When analyzed computationally, 54,000 marmoset vocalizations revealed receiver-specific modulations. Across nearly 100 million years of evolutionary separation, ocean, savanna, rainforest, different animals had arrived at the same technology, personally addressed acoustic names. This pattern suggests something fundamental about complex societies. When species separated by vast evolutionary distance independently solve the same problem, it reveals a universal law. There is a threshold of social complexity beyond which naming becomes essential. At a certain point, when groups grow large, relationships become fluid, and visual contact is regularly lost, anonymity becomes lethal, and identity becomes currency. How durable is a name? In the Sarasota Dolphin Whistle Database, a 50-year archive of recordings from a single population, individual dolphins have been tracked across their entire lives. Their signature whistles, recorded at age 1, remain virtually identical at age 45. The geometric contour is fixed. The frequency-modulated shape never deviates. This stability is not accident. It is the foundation of a social architecture built entirely on the persistence of identity. In one remarkable case, A dolphin separated from its former companion for 23 years was played a recording of that individual's signature whistle. Instantaneously, the dolphin responded. It recognized the call. After 23 years of total separation, the name was still held in memory. This represents the longest documented social memory in any non-human species. But names are not encoded in sound alone. In murky water, dolphins taste each other's urine, a form of chemical recognition. When researchers played a dolphin's signature whistle while simultaneously exposing the animal to that same individual's urine, the response was unmistakable. The dolphins hovered longer, showed higher engagement. They had cross-referenced two sensory channels and found them in agreement. Identity existed in multiple registers: acoustic, chemical, verified across senses. In 2023, researchers discovered that dolphins possess electroreception, the ability to detect weak electrical fields through specialized sensory organs in the snout. This capacity allows them to sense the bioelectric pulses of prey, but it also means they could perceive the electrical fields generated by other animals moving through water. Yet another channel reinforcing the persistence of a name. A dolphin's sense of another individual is not encoded in a single sensory stream. It is a multi-layered, redundant file. Acoustic, chemical, possibly electrical. The identity of another being is recorded with such fidelity that it can be recalled through any sensory pathway that remains available. In darkness, the name persists. In turbid water, the name persists. Across decades of separation, the name persists. This multi-sensory architecture for maintaining identity suggests something profound about the structure of dolphin consciousness. When we look in a mirror and recognize our own face, we call it self-awareness. Dolphins do the same. They look at themselves and recognize themselves. But their sense of consciousness extends beyond the mirror. They hold the identities of others with extraordinary fidelity. They maintain these identities across decades. They access these identities through multiple sensory channels. They use these identities to navigate complex social hierarchies and predict future behavior. The dolphin does not write. The elephant does not read. Neither has discovered calculus. Yet they have arrived at something we thought was uniquely ours: the ability to assign symbolic names to individuals and use those names to maintain relationships across time and distance. In 1965, researchers heard dolphins producing unique whistles in the darkness and wondered what they meant. 60 years later, we know. Those whistles are names. They are learned. They persist. They are used intentionally to address specific others. They carry reputation and memory and identity across the vast emptiness of the ocean. In the darkness beneath the waves, a dolphin calls out with a name that persists across the darkness of the ocean, or across decades. The sound is simple, a modulated whistle. The meaning is profound. The elephant rumbles across the savanna, using a name that exists nowhere else in nature, an arbitrary symbol that points to a specific individual. The parrotlet chirps a name that will draw its distant companion back across the jungle. The marmoset cries out in the canopy and hears its own name echo back. In how many other ways do we misunderstand the minds around us? What other forms of intelligence have evolved in worlds we have never entered? Depths we cannot reach, forests we have never seen. The question is no longer whether animals can name each other. The question now is, how many languages have we been failing to recognize?